All right. Welcome into lesson 17, Algebra 1, folks. I hope you had yourself an enjoyable Thanksgiving break, whether it was good food or relaxing or seeing a little bit of family, and most importantly, staying safe, no matter how you spent your five or so days off. We're transitioning back into the remote 2.0 learning. Let's just pick up where we left off with lesson videos and then choosing some choice activities here. So we're going to dive right in here on this beautiful Monday. Here, the focus of really this next 3 weeks is going to be this right here, the systems of equations. Okay, so equations are something we've worked with this year, you've worked with for a few years. But what a systems of equation is, it is two or more equations in the same variable. All right, and what I mean by that is just instead of seeing one equation, we're going to see two. Okay, and there's three main ways that we can solve these systems of equations. We're going to take a look at the first one today, which is graphing. Okay, and today's they're actually going to already be graphed for us. So we're going to kind of more so look at this next piece here, the solution, right? A lot of the focus here is going to be on finding the solution. Well, today it's going to be more so on identifying the solution. So just where and what does the solution look like? How do we find it? And then how do we make sure we label it? Okay, so one thing we're going to see is we can always solve these systems of equations graphically. Okay, on a graph, we're just looking for the point, right? The one point where the two lines intersect. Okay, that's our solution. We try to see where two different lines on one graph intersect. We're going to see some examples below. When we solve it algebraically, okay, we're going to do that more so on Thursday this week, and then kind of the next 2 weeks after that, we'll be doing it algebraically with some math. But it's the same thing. We're looking for the point. We just don't get a graph. So we're trying to see the one point that makes both equations true. Okay, meaning something like we've seen earlier this year, like a 9 equals 9, right? Or like a 13 equals 13. That's what makes something true. This is not true. 8 equals -2, right? So that's more the algebraic. That's not our focus today, but just something that we'll pay more attention to the second half of this week and the 2 weeks that follow afterwards. Solution types. I want you to write this down. There are 3 different types of solutions. 3, okay? Here they are. There's one solution. Okay, we're going to see this one solution. All right, and what does that mean? It's just these lines are intersecting. Here's an example of a line and a line. And this right here would be our one solution. And we write that point as just an XY pair. Okay. Our second example here is there's no solution. Okay, and what does no solution mean? What do two lines look like that have no solution? Keep in mind, the solution is where they cross. Well, if there's no solution, it means that they're parallel lines, right? And there's just nowhere at all over here that has a spot where they intersect. Those two lines will run parallel to each other. They'll never intersect, even if they go on and on both directions. So for no solution, we can just simply put this symbol right here, just kind of like a 0 with a slash through it, meaning there's no solution. I can't give you an XY pair because there's no point in which they cross. Last but not least, this one's a little rare. You'll see it though. Same line. This is infinite solutions. Okay, we just use the infinity sign, which means, right, there's not one point that they cross. All right, there's not no points that they cross. It means they are exactly the same. And this is what you'll see. There's my one line, and then we'll see this dotted line kind of back here. And that just means, hey, there's two lines here. Here's one. Here's the other, and they're exactly the same. This must be a solution. Same with this and this and this, because all of those points are where those lines are touching. They're touching to get the whole entire time, right? There's going to be infinity solutions to that example there, okay? Down below, we're going to see some that are already graphed, and our focus is going to be, can we write the equations of the two, find the solution, and write the solution, okay? So here's example number 1. We see this graph has 2 lines, so it's a system of equations. It has 2 equations. They're already graphed for us. I want us to focus on what are those equations, and then where and what is the solution. So this first one here, I'm just going to call this one line number 1, right here, this guy. We're going to be writing them in slope-intercept form. right? Should be comfortable with that by now. And then we're going to identify the solution. So this line number 1, the solution is y equals, I'm going to count from this dot to this dot. My slope looks like it's a rise of 1, 2 and a run of 1, 2, 3. So up 2 over 3 for my slope. And then it has a starting point of positive 2. So there's my first one. Here's my, I'll call this one line number 2 here. I need to count my rise over my run. So from now, let's switch up the colors here just for the sake of making this a little bit easier. Let's go with the red. I need to get from this dot to this dot for my rise over run. So I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3. Y equals 9 over 3x, and that looks like it has a starting point of -1, -2, -3, -4, -5, -5. So that's the equation there of those two lines. And then the solution, I'm going to clear a little bit of this here just to get this stuff off the board. And then our solution again is where they cross. If they cross, these ones do, they cross right here at this point. That point is, looks like on the x, 1, 2, 3. So the point 3, comma, and then 1, 2, 3, 4. So that one coordinate point where they cross, the solution is at 3, 4. Okay. Let's go ahead and hop right into example number 2. I'm not going to spend too much time on these. More so the focus of just, hey, what's the solution? Where is it? How do I write it? And then the writing the equations themselves is not a new skill. This is a skill that's a middle school skill. You guys had some practice on it over the last few lessons as well. So let's call this one line number 1. I'm going to write its equation first. I need to get from here to here. I need to find my slope. Looks like that goes up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. So that's 5 over 5. 5 divided by 5 is 1. Just going to make life easy on myself and call it y equals 1x. And it has a starting point, a y-intercept of 1, 2, 3, positive 3 plus 3. There's my first line. Let's clear this. My second line, let's go ahead and rock a new color here. We can go with this green. Can we get this away here? Maybe. I need to get from here to here. So now I'm going to go down 1, down 2. It's a -2 over 1, 2, 3, 4, 5. Y equals -2 over 5x. That's my slope. And then a starting point of -1, -2, -3, -4, -4. Do they cross? Yes, they do. Where do they cross? We easily see them crossing right here. I just need to know the location of that point. So that point is at -1, -2, -3, -4, -5, -5, comma, the y coordinate is -2. So there we see our first solution, first and only solution to number 2. That is where they cross. Let's go ahead and check out example number 3. Let's keep rolling. Here we see a couple negative lines, right? Negative slope. So we know that we're going to be writing a negative slope. Let's go ahead and call this one number 1. And let's find its equation. So I need to get from this dot to this dot. So I'm going to go down 1, down 2, down 3, down 4, down 5, down 6, and then over 1, 2, 3, 4, 5, 6 as well. So -6 over 6. 6 divided by 6 is 1, but it's a -6 divided by 6. So we're going to get y equals -1x. And it has a y-intercept of a positive 1, so +1. That's that first line. Let's go ahead and get those out of the way. We're going to look at line number 2. We'll call this one here line number 2. So I need to get from here to here. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1, 2, 3, 4, 5, 6. So we get this 12 over 6, -12 over 6. We like fractions, but if I can simplify them, I like to do it. Well, -12 divided by 6 is -2, so let's call it y equals -2x. And then I need to know its y-intercept, so that'd be 1, 2, 3, 4, 5, 6, 7. It starts at +7. There's my system of equations itself. And then I need to find and write down the solution. So where do they cross? They cross right here. What are the coordinates of that point? So that point is at 1, 2, 3, 4, 5. It looks like 6. So +6, and then down 1, 2, 3, 4. That y-coordinate is a -4. They cross at one point. There's one solution, and that solution is at 6, -4. Let's keep rolling here into example 4. So we get our first horizontal line. Let's go ahead and call this one number 1. So I need to know, what's its slope? Well, it has a slope of 0. Okay, so we're just writing down really, where does this line cross the y-axis at? Well, it crosses, it's y equals, it crosses at 1, 2, 3, 4, 5, 6, 7. So the whole entire equation for line number 1 is just y equals 7. I'm going to go ahead and clear this stuff. Whoops. Maybe clear this stuff out of the way. And then I need to find the equation for this next line. We'll make it purple. We'll call this one line number 2. I need to get from here to here, find this slope. So down 1, down 2, down 3, down 4, down 5, and over 1. So y equals in -5 over 1. -5 divided by 1 is just -5x. And it has a starting point of +1, +2, plus 2. And do they cross? They do. We see it. They cross. There's one solution. We see that solution right there. And that's at the point -1 is my x pair. And 1, 2, 3, 4, 5, 6, 7. 1, comma, 7. That makes sense because that 7, right? This whole entire equation here's line's equation is y equals 7. So we know that that y had to be 7 if there was a solution. 2 more examples before we head out of today's notes, I believe. Yes, let's go into example number 5. So we'll call this one line number 1 and this one line number 2, maybe. Right here. And let's check out line number 1 first. So I have a slope of 1, 2, 1, 2, 3, 4, 5, 6. 2/6 can be reduced to 1/3. So I'm going to say y equals 1/3, and that's positive. It's a positive slope. It's going up and to the right, and it has a starting point of +1. We notice that this next line runs parallel to that. Why am I telling you that? Well, it can save you some time. If you know that they run parallel, they have to have the same slope, right? Up 1, up 2, over 1, 2, 3, 4, 5, 6. It's the same thing, 2 over 6, which reduces to 1/3. Y equals 1/3 x. That's good. We see that. They have the same slope. That means they're parallel. We've done that correctly. But they don't have the same y-intercept. This one has a y-intercept of -1, -2, -3, -4, -5, -6, -6. A solution, remember, we're looking for where they cross. These ones, they don't cross. Right? There's not a single point on these lines, even when they go forever left and right, that there's just no solution. Right? So we're going to go ahead and put that symbol that says no solution. No solution. And last but not least, let's check out example number 6 here. Example number 6, we see that 1, right? We see we're going to call this one line number 1. And then we can call this one line number 2, this dotted line, right? Though we see they're exactly the same. So something should be going off in your brain like, hey, right? We still need to write the systems of equations. So I need to find the slope and the y-intercept. So I need to get from here to here. Let's go ahead with the purple line. So down 1, down 2, down 3, down 4, down 5, and over 1, over 2, over 3. So I have y equals -5/3. 5 divided by 3 would be 1.66. We don't like that. So we're going to leave it as -5/3 x. And it has a starting point, a y-intercept of 1, 2, 3, 4, -4. We know these lines are exactly the same. So that means that we can go ahead, and that means their equations have to be exactly the same. So I'm just copying this down here because their lines are the same. The solution, again, means every point is touching, right? These 2 points are shared. These points are shared. These points are shared. So we remember that's that last type of solution, and we call that that symbol there, that is infinite solutions. All right, that's all for today's notes, right? Some things to emphasize, right? How many different types of solutions are there? There are 3. What are those 3 types? They are one solution, no solutions, and infinite solutions. What do they look like? One solution looks like, hey, there's one spot where they cross. No solutions is, hey, they never cross. There is no one point where they cross. And infinite solutions means it's the same 2 lines, the same 2 equations, so each point is touching everywhere. There's an infinite amount of times where those 2 lines are touching. This is, again, a focus on graphing. They were already graphed for us, so we had to go ahead and write the system of equations themselves, the two equations, right, 1 and 2, and then find if they crossed, where was it, and identify that solution. Go ahead and hop into today's assignments, and we'll be back for lesson 18 tomorrow.